Determination of atomic mass of positive ions by Dempster's mass spectrograph. It was designed by Dempster in 1918. It is a simple apparatus which measures the abundance of ions of different masses in ionic beam. If the positive ions of an element are accelerated through a certain potential, they gain the same kinetic energy so that magnetic field alone acting perpendicular to their path. We will be able to analyze the ions with regards to their masses. The experimental arrangement is as shown in the figure. The anode A is a metallic cylinder with its front surface C is coated with a salt of the element under test and is heated electrically. Filament F is heated electrically by the battery B1 emits electrons. The filament is maintained at a potential difference of about 50 volts with respect to A by using another battery B2. The electrons are made to incident on element. The ions are liberated. These ions are collimated into a narrow beam by the slit S1. The positive ions are accelerated towards the slit S2 by a variable potential difference. The potential difference between the slits S1 and S2 be V, say capital V. If M be the mass of the ions and E be the charge, when they acquire the velocity V, and then is given by half mu square is equal to EV. Half mu square that gives the kinetic energy of the ions, EV, potential energy. This is equation number 1. Then after that V is equal to root of 2EV by M. This is equation number 2. Now the ions enter a vacuum chamber, say G, vacuum chamber G. The ions are subjected to a magnetic field of strength B at right angle to plane of the diagram. The ions are deflected through a semicircle towards the slit S4, defined by 3 slits S2, S3 and S4. The magnetic field B makes the ion to travel a circular path of radius R. So look this diagram. So this is the semicircular path. That this is S1, S2, S3 and S4. They are these 4 slits. There is G vacuum chamber, E electrometer. So and then BeV is equal to mu square by R. Here BeV that gives the force experienced by the ions in the magnetic field. mv square by R, so called centripetal force due to the ions which moves in the circular path. Then after that R is equal to mv by be. This is equation number 3. Then substituting equation 2 in 3. So this is equation number 2. Then substituting in place of v, then we will get R is equal to mv by b is equal to m by b root of 2ev by m. Then further R is equal to root of 2mv by b square e. Then squaring on both sides, so then we will get R square is equal to 2mv by b square e, and then e by m is equal to 2v by b square r square. For the particular value of V, only the ions with the specific charge given by the equation 3 are collected by the electrode P, and the current is registered by the electrometer E. By adjusting V and B, the ions are made to traverse a circular path of a fixed radius. Then a determination of the masses of the isotopes. In the actual experiment, the magnetic field B is kept constant and ionic current is measured by electrometer for various value of V. The graph is plotted with this current against V. The graph will show sharp peaks at these values of V corresponding to the value of M. The above figure shows that the masses of two isotopes of potassium, the mass number are 39 and 41. The relative abundance of the isotopes can be identified from the relative heights of the peaks. Then uses of the mass spectrographs. Mass spectrographs have been used by many research workers to determine the isotopic masses of all elements in the periodic table. And second one, mass spectrographs have been employed to separate small quantities of pure isotopes. Thank you.